Work energy theorem. The work energy theorem says the work is the work is change in kinetic energy. Delta K denotes the change denotes the change in kinetic energy. Kinetic energy. In some books, they use delta T also, not a very big issue in some books. So we will use this expression. Now we know that we can write this expression as delta K is equal to W, that is nothing but F dot, let us take it as ds. Now, F already we know that is equal to MA, where A is dV dt, where A is dV dt. Now, delta K is equal to W is equal to F. F in place of F we will write M dV dt dot ds. Now this dt will put it under ds. So delta K would be now M dV dot V. They're both in the same direction. Now, since they're both in the same direction, we will take M delta K equal to M V dV. Now, we will integrate this equation. So now we will integrate this equation from initial velocity u to capital V, some V. So on integration, I've already told you in the other chapters number of times, this will become mv square by 2. And now you will take the initial, you put the initial, the lower limit and the upper limit. So this becomes mv square by 2 minus u square by 2. You open up the brackets. Delta K is equal to mv square by 2 minus mu square by 2. This is nothing but K final minus K initial, and this is actually that's why you are seeing, because of this expression I got the value of delta K here. That's why W is equal to delta K, which is nothing but delta K is nothing but changing kinetic energy, K final minus K initial. Now supposing what I do is that I take the initial velocity as, let me take the initial velocity u as 0 and let v be same as v only, the final velocity. So this expression, this expression becomes, see, k initial comes out to be 0 because u is 0, as u is 0, and k, let's call k final as k. So k comes out to be half mv square. This is the definition of kinetic energy. And it comes from there. Now, more very, very important discussion on this expression. On this expression, W is equal to delta K. Now see what exactly this W is all about. Now, W, again I write W is equal to delta K. What does this W signify? This signifies WA. I'll explain you all this. WNC, WC equal to delta K. Now where, let me write down. WA is the applied work done by applied force. Work done by applied force. Next, WNC, work done by non-conservative forces, conservative, like for example friction. When when the body is moving and the friction is acting on the opposite direction, non-conservative forces, just a minute, non-conservative forces, this is V, non-conservative forces. The next is WC, work done by conservative forces. Conservative forces. Now, see one thing. I need to tell you one thing. Earlier, I told you in conservative, in the last video, I may have told you somewhere that if in conservative force field, F can be written as minus du dl. dr I wrote there, I'm writing it S, no problem, it is just a matter of symbol. Now see one thing, W conservative, see what will W conservative come out to be? You know this is conservative force, conservative, FC. FC dot ds. You have this case. This force, I'm using the force. Force is in the direction of ds. This FC is in the direction of ds. So this will now become FC ds. Now things will be easy. In the direction, so dot product will remove, will become cos 0. Okay, take it this way. Then in the same direction, now this becomes FC ds. Put the value of FC here. Minus du ds into ds. Now this is you integrate du from u initial to u final. This is capital U, not small u. This is mind you, this is capital U. Mind you, this is capital U. Du. So u initial and u final. So this will be minus u initial, u final minus u initial. And this is nothing but minus delta U. This delta U means change in potential energy. This delta U means change in potential energy. This delta U means change in potential energy. Change in potential energy. Potential. Because I told you once that the force can be derived from the potential energy in a conservative force field. I told you in the last video. See, I'll write it down here again. Potential energy. Now, I'm writing that in conservative, conservative force field, force field, the in the conservative force field, uh, the force can be derived out of potential. See, the force has been derived out of potential. Force is derived out of potential energy. Out of potential energy. Let me write potential energy. It is possible only in conservative force fields. Now see, we have one very good, let me draw this for you. This is something very, very, very important for you. This concept. One, this concept that is very, very important for you. The other, of course, is this one also. You cannot neglect it because this concept comes from this concept. Now, let me do this. Now, the next most important point is what work comprises of this whole stuff. You cannot neglect this. This work is not just simple work. This is applied, non-conservative, conservative. All of this together is this work. I hope you have understood. Now you see, I'll rewrite that expression. W applied plus W non-conservative plus W conservative is equal to delta K, where I already know just above W is minus delta U. I hope you now know it. Suppose, this is the supposition first supposition, and this is a very, very important supposition, that work applied is 0 and work non-conservative, work done by applied forces is 0, work non-conservative is 0. Then if you see in this will become 0 plus 0, and you will use this expression plus minus delta U, and this will be equal to delta K. So now this is minus delta U equal to delta K. Bring all on one side. Delta U plus delta K is equal to 0. And now you will see this is U final minus U initial plus K final minus K initial is 0. So U final plus K final is equal to U initial plus K initial. So this is a very, very important concept known as conservation of mechanical energy. This is what is known as conservation of mechanical energy, of mechanical energy. Now, this is what you basically need to do problems. This idea. This is nothing but, in some books they write, delta mi, mechanical energy, is equal to is equal to zero. Is equal to zero. This is equal to zero. That is, if you write m final is equal to m initial, where m final is nothing but u final plus k final is equal to u initial plus k initial.